Hi, thank you for coming to this talk. Pixels is one of those events that are really great opportunities to share. And as a data scientist, I'm always sharing knowledge and discussing ideas, so it feels great to be here. Books are and research papers are amazing resources for knowledge, and you need them to keep up with the state of the art and to learn core concepts, algorithms, and proofs of convergence. But there are also things that are often left out and that are as important as having a great machine learning approaches. And today, I'll use my experience at Feedzai to talk about this stuff that doesn't always come in books. And these are some of the things that help Feedzai become one of the leading fraud detection companies in the world and to really drive change in the fintech market. So I've chosen just 3 topics: technology, and why it's almost never the problem, domain, and why you need to really look into the data and know your domain, and people, and why processes and team performance are really critical to success. When we talk about unbalanced classes, books usually talk about 1 to 9, and at this point, they will start suggesting techniques like smooth, oversampling, random undersampling, stuff like that. But at Feedzai, we have 1 to 10,000. And this is a huge unbalancing. And if you read the literature, this is usually not even addressed. And all your classifiers will typically fail under these conditions. You can resort to some techniques like anomaly detection, peer group analysis, breakpoint detection, but if you look closely, there is also, in our case, a workaround. 1 to 10,000 is basically 1 basis point of your data being a fraud example. That's 0.0001%. But we do have a ton of data. And this tiny percentage turns into a very acceptable number of positive examples. So now you have a different problem. Now you have a problem with scale. So 100K for fraud transactions, but you also have that billion of non-fraud transactions. So you must think of ways of sampling your data. And you can't even do a random undersampling because that won't work well with the kinds of features we do. We have to think of more intelligent ways of sampling your data. And speaking about scale, at Feedzai, we are obsessed with scale. Every time we are thinking of something like a new feature, a rule, a model, a database, or even just a small piece of code, we are always asking ourselves, will this scale to billions of transactions? And we do it because we really need to. To put into perspective, last year we processed more money than all of the NASA budgets combined ever since its inception. Now, I don't know if this says more about NASA or Feedzai, but it's really an impressive number. And what is even more impressive is that we have to process all of these transactions and do it under 5 milliseconds with really tight latency SLAs and availabilities compared with big players such as Google, Amazon, Microsoft, and so on. And basically, you need a really fast system that is very stable and always available. All it takes is a hiccup of 1 second, and there goes your SLA. You're already breaking it. So you need to simultaneously optimize for latency, throughput, and availability. And this is really hard to do, particularly when you have a dynamic system where you can change rules, update lists, update profiles, and all of these in real time. So everything is changing in real time. And for example, one of our storage solutions is Cassandra. And we had to squeeze it so much that at some point we had to coordinate with the core development team for Cassandra for them to be able to really support our use case. So there's the need for a development of highly optimized code, but at the same time using the adequate technology. For you to understand why these latencies are so hard to achieve, I need to show you basically everything that happens under the hoods on a typical 3 millisecond transaction that we have. So first comes the data from the client through a pre-agreed API. And that raw data is used to update profiles, real-time profiles. And these can be profiles like the average amount spent by this client in the last 8 hours, something like this. And then you can populate with historical profiles, so stuff like the amount usually spent by the user over the last 3 months, stuff like this. And you can also use some external enrichers to give you extra information, like is this IP from a Tor node or from a proxy or whatnot. And at this point, you have everything you need to start making a decision about this transaction. You have all the information you need. And first you can check if, okay, is this under one of my rules or is this on a whitelist or blacklist? Can I block, can I accept? And if it falls under one of these conditions, you can already feed it into, you can already produce the decision and feed it into Alert Manager, which is a part of our product that allows you to have feedback from analysts. So the analysts can manually review your decision and if needed, they can correct it. And that correction will be reflected on the real-time system. And of course, you can also feed this transaction into a machine learning model that will produce a risk score. And according to the risk score, it will produce also a decision that can also be fed into these analysts that will manually look into that. And then it all syncs into an historical database that will store all your transactions, all your profiles, all your feedback from Alert Manager. And it can also be fed other information like confirmed fraud from other sources or chargebacks and so on. And remember, all of this happens in about 3 milliseconds. And this is really, really hard to achieve, particularly when you have hundreds of features and lists and profiles and everything at the same time. It's like having a Formula 1 car stopping at the pit stop, and where you have to change your tires, you have to fuel, you have to make mechanical adjustments. Except this car doesn't have 4 wheels, it has hundreds of wheels. And you have another car coming in full speed right behind you. So this is really, really hard to do. And with so much going on with data, features, profiles, enrichers, everything at the same time, you really need to be paranoid when it comes to experimental design. It's not enough to have features. You need to have features that you can handle with production data and they can fulfill your SLAs for latency and whatnot. So you can have a great feature, but that takes too long to compute in production, so you cannot use it. You don't have that feature anyway. Or if your production data has missing values, then your model that you're training must handle missing values. Otherwise, it's not going to work in production. So the way you compute the features must replicate what is going to happen in production. And this is really, really hard, particularly when you're simulating the full system. The model, the rules, the external enrichers, which have information that can change every day, and you have an historical data set of, I don't know, months. And this is why the data science team at Feedzai is constantly discussing their experiments, their experimental setups, and their assumptions. And this is really important that we always keep communicating and discussing what we are trying to experiment. So, as you can see, technology is an issue, but it's not a showstopper. You can always go around and have some more or less complicated solution for a technological problem. But knowing your domain and looking at the data is much, much, much more important. That's where you are really going to be able to get your job done. So let me start with an example from another domain. If you design a speech recognition system that has an error rate of 5%, you are already at superhuman level. So as a data scientist, that is going to be your goal. I need to have a superhuman system. So you need to get more data, better machine learning models, and so on. And each increment may be small, but you know that eventually you will get there. Because when you're using a voice recognition system, you want it to understand what you're trying to say. Like in Siri or Alexa, you want the system to understand you. You're not going to do a more tricky accent just to fool the system. That doesn't make sense. But with fraud, that's precisely what happens. As soon as you put the model in production, the fraudsters are going to start having their fraud transactions blocked, and they're going to understand, okay, this no longer works, I'm going to switch to something else. So they are actively trying to fool your system. So you can have a great model, you put it in production, and then as time goes by, the model loses performance. And you need to know what is happening, and you need to constantly improve the model and iterate on that, and creating new features and new approaches. And this is why at Feedzai we have a very strong culture of looking into the data. No matter how large your data set is, you will have to dig into the data and look at the transaction level. You need to look at the transaction, what is happening. Not just using aggregate metrics like the mean, the variance, quartiles, whatever. Because if we rely on indirect metrics, you can fall into the Ascombe quartet, where you can have different data sets with the same mean, the same variance, same correlations. And if you look at these metrics, they are the same data set. But when you plot it, when you look into it, you know that they are completely different. So I want to tell you 4 stories of how really looking into the transactions helped us understand what was behind the pattern and the attack. So the first was, at some point, we were building a model for a client, and by analyzing the data set, we noticed that we had a tracking cookie from the browser with an abnormal number of transactions, of events. This was for an account opening use case. So you might expect someone to try to open an account a couple of times, gets rejected, quits. This one had hundreds of attempts. Clearly something very suspicious. So we dug deeper. We went to the transactions and we started looking into the transactions. And what we have observed was that the application name for these events were ordered alphabetically, just like in a phone book. And when we presented this to the client, which had been working with the dataset for a couple of years already, they told us, oh, we remember that one. It's the Cookie Monster attack. So, although this was a particularly large attack, this pattern was kind of common in the dataset. So by designing features to detect this, we managed to improve the performance of the system, because this was also present in other types of attacks. The second story comes from e-commerce. So when you're buying something online, you always need to fill your email. So do fraudsters. And many times the fraudsters don't care about the email. They just have to put something there. So they put some random stuff. Or maybe they want to make it look a little bit more legitimate, so they put the first and last name, but then add some dates just to make it work with some script and make the transactions look different across different orders. And they sometimes even use seemingly legitimate emails, but in registered domains that are typos for normal domains, like Gmail or something like that. So just by looking to these examples, I can already think of at least 5 or 6 features that can help us detect these patterns and improve our models. So it's important to look into the transactions themselves. One of the things that amazes me most in the fraud landscape is that it's really a market. You have people using stolen cards to buy stuff and then later resell it, but you also have people selling the cards themselves. So, and as a seller, you want to have a good reputation because you also have competitors. So you start having guys selling credit cards and saying, look, I'm going to sell you the card, but with guarantee. If it doesn't work, I'm going to give you back the money. So that's pretty nice for the buyer, right? And what we've seen, so there's an incentive here for the seller to test if the card is working or not. Otherwise, he's going to have to give back the money. So he tests the card first and then sells the card. So we've started seeing these on our data. We detected that many times there are small amount dollar transactions in the data prior to the fraud attack. So it's like a prelude to the attack. And knowing these might help you improve your detection rates. And as you've seen, many times it's not enough to look at 1 or 2 transactions. You need to look at the bigger picture and how some transactions are linked together. Many times the fraudsters make one fraud transaction and then change something just to make it look like a completely different customer and then try again. But if you look closely, these orders are linked either by email or IP or shipping address. And you can even do indirect linking. And you see, okay, the last one is not linked to the orders, but it's linked to the previous one by IP, which is in turn linked using the shipping address to the first one. So doing these, you can really, really capture the bigger picture of the fraud attack. So far, we've seen that technology is an issue, but not the problem. We've seen that knowing your domain and looking at the data is really important for an effective data science work. And by the way, as a data science, if you don't know your data and you don't know your domain, you're not doing data science properly. That's basically your job as a data scientist, is to understand the data and the domain. So the final problem is people. If you're solving a real world problem, then you're going to have to deal with people problems. And the first one is that nothing is well defined. We usually say that our work at Feedzai is the exact opposite of a Kaggle challenge. On Kaggle, your problem is well defined. They tell you, look, this is your task, and we want you to accomplish this. With Feedzai's clients, many times they don't fully know their scope. They don't fully know what they want to achieve. So we have to sit down with them and discuss their needs and really understand what they are trying to accomplish. Because saying we want to block fraud is too broad. We really need to know what they want. On a Kaggle challenge, your data set is well defined. They give you a train set and a test set with blind labels, and they tell you, okay, that's your data. And that's a couple of files. At Feedzai, many of our clients have data coming from multiple systems, many times incompatible between themselves. And it's really hard to clean and join all of these data, because sometimes it's really impossible even to join the data. So it's hard to have a clean, usable data set. As an extreme example of this, a while ago, we had to join 10 million files for a 15 terabyte data set. So it was like huge. And on a Kaggle challenge, your labels are well defined. You have a column there saying label. It's easy. You know the label. At Feedzai, I have many clients saying, look, this is our fraud. Oh, but in that case, that's also fraud. Oh, but in that exception, then it's not fraud. So it's difficult to know what is really, really fraud. It should be easy, but sometimes it's not. And they even have sometimes the system that receives the labels, the confirmed fraud, is incompatible with the system that stores the transactions. So you cannot even join the labels. So it's really, sometimes it's really hard to have clean labels for your data sets. And finally, on Kaggle, the metrics are well defined. They say, okay, this is the target metric, this is the formula, do your best. At Feedzai, we have clients using recall, using precision, using false positive rate, false positive ratio, calling FP rate to FP ratio, so they were mixing names. So we need to sit down and agree what is what. Saying the names is not enough. We need to sit down and really show the formulas and agree on what they want to evaluate. The world is always changing, as you know, and that means that nothing is stable. Couple of examples. In the United States, they've been rolling out cards with chips, like we have here in Europe for a long time. And these cards are much harder to counterfeit, which means that in the next few years, we are going to see a shift from card-present fraud in the United States to online card-not-present fraud. And this is important because these are two different types of fraud, and the patterns there are going to be much, much different. Also, the emergence of new payment methods like Apple Pay or cryptocurrencies will give rise to new user behaviors and, of course, fraud schemes. So we need to pay attention to that. And finally, new products and online services and whatnot are really a fertile ground for fraud. To give you an example, on a well-known taxi app, there was a hacked version of the app that you could buy, and then you could ride all the taxis you wanted for free. Pretty nice, but someone was paying, and what was happening is that the taxis were being paid using credit cards stolen from other people. So the client didn't even need to know. They just paid, and that's it. I pay the app, and I have free taxis for life. So you need to pay attention that the world is changing, and you need to adapt and learn these new approaches and fraud schemes. And of course, nothing we discussed previously would be really possible to handle without an effective team. And a data science team is like a firefighter team. You cannot describe how to fight a fire just by discussing the latest models of fire trucks, extinguishers, boots, gloves, whatever. So a discussion about the gear is not enough. You need to discuss how to communicate, how to coordinate, how to handle external events like winds and people, how to advance, when to retreat, all of these. And in a data science team, it's the same. It's not enough to discuss models and features. You need to know how to share knowledge to continuously improve models and features, how to hire new people, how to train them, how to deal with ever-changing adversaries, and how to replicate the production environments for us to know what is going to happen in production. So, how do we do it at Feedzai? Well, first, you need to build a safe environment for open discussion. people must feel safe to say, I don't know. Or to say, look, that thing I said that I was doing last week, well, it turns out it wasn't pretty much correct, so I'm trying to fix it this way. I have to have this kind of open discussion without anyone kind of blaming someone. That doesn't work. And you also have to have an environment where nobody tries to steal other people's ideas. That's really important. And when you have that, then sharing knowledge becomes possible. And at Feedzai, we have a weekly meeting where everyone from the worldwide data science team gets together, either remotely or in presence. And we get together and 2 or 3 projects present what they've been doing in the last week and show their experiments and show their results. And it's our collective responsibility as everyone in the team to look and listen and try to figure out if those experiments make sense, if those experiments are actually showing and proving what we want to prove. And if not, we should say so. We should say, okay, that's odd. Should we do something else? Should be something different. But in the sense that you're not blaming the person, you're just trying to make everyone's work better. And that is really important. And these meetings also serve a second purpose, which is to build cohesion amongst the team. And this is really important because when you have teams scattered across projects, countries, continents, this is the glue that will stick everyone together and that will allow you to have that common sense of purpose and that we are all trying to accomplish the same. And the last thing is that you still need to have fun. And if you're not having fun, you're doing it wrong. You should have a team that gets along well. The people should like each other. And you can't really have this if you're not hiring the right people. So at Feedzai, we are really obsessed in hiring the right people. Last time we checked, we had an acceptance rate of about 2%, which is really low and comparable with the best universities in the world. And these are some of the things that we search for in our candidates. Grit, the ability to persevere under adversity, because there will be plenty. A fixer mentality, the mindset where if you see something wrong, you fix it. You don't wait for someone else to fix it. It's not other person's problem, it's also your problem. Modesty, the ability to admit that you don't know something or that you have much to learn. Initiative, ability to give credit, team spirit, and so on. This is really important. And when this photo was taken, we had a much smaller team. Right now, we are 5 times bigger, but these values are still very present in our company DNA. And this shows you how dedicated we are in keeping these values. This is really what we want for Feedzai. So, we ask all our newcomers to present themselves to the company by telling us 3 things: what they love, what they value, and what they hate. And a couple weeks ago, one of our colleagues collected all of these answers into a word cloud, and this was the result. So teamwork, honesty, humor, integrity, humility, friendship, all of the things I've just told you are all there, supporting what makes Feedzai a really great company to be. So, thank you very much.
Any questions?
Hello, thank you for your presentation. Regarding your evaluation of your season, do you rely on the data that your clients provide you regarding the accuracy, precision, or do you try also to be kind of red hat testing, like penetration testing, where you have elements of your team trying to outsmart your algorithms?
So let me see if I understand the question. What you're asking is that do we rely on the metrics that the clients are giving us, and if if we also compute them by ourselves? Is that the question?
No, if you have, if you turn around to a colleague of yours and tell him, or try to see if you can fool this our current, how can I say?
So
try to break our system today.
So if we ourselves try to break the system,
exactly.
Well, we don't always do that. Sometimes we try to see, but many times what we do is to try to separate sets with very different fraud patterns and see if the model is still able to do it. But we don't often kind of ourselves try to break the system. On a live system, you cannot do that because that would be kind of illegal, or the client might not agree to do that. But offline in the lab, sometimes we try to replicate that, yes.
No more questions? Okay. Thank you.
Thank you very much.